Hello and welcome back. Today we are going to be starting our new unit, Sensation and Perception, learning about how we make sense of the world around us using all 5 of our senses and how that information is turned into something our brain can understand. And then of course, how does our brain make sense of it? We're going to go ahead and get started here with just an introduction to what sensation is before diving into each of our 5 senses. So let's go ahead and get started. So what exactly is sensation? Sensation is the process in which we receive information from the environment. So everything outside of our bodies coming in for our brain to perceive. So this involves a whole lot of different processes. Coordination from the receptors in our skin and in all of our senses, our neural pathways, the sensory processes, the different parts of the brain, and how this information is transduced into something our brain can understand. It's a complicated process, but the more we understand it, the better we can understand how we make sense of the world. And that's really what perception is. It is selecting the pieces of the environment that we want to pay attention to, and then interpreting that information from the environment. And we'll talk about that more a little bit later. But sensation and perception work together to help us to both build our understanding of the world and make sense of things that we have already seen. And we call this top-down and bottom-up processing. Top-down processing is when we use our past experiences and expectations to make sense of the outside world. Bottom-up is when we're receiving that information from our senses and sort of like building our understanding. The way you can kind of think about the difference between top-down and bottom-up is consider bottom-up would be like the first time you've ever seen a chair, and you look at it and you take in all of its component pieces, you feel it, it has a flat bottom, it has a sturdy back, it has 4 legs, whatever it is that you are seeing and experiencing, and you're building that understanding of what a chair is. Now, every time you see a chair, whether it's the same one or a different one, you can now use your past experiences and your expectations of what chairs look like to be able to identify the chairs that are in your environment. So you don't have to rebuild that understanding every time. Now you can use top-down processing to be able to identify it quickly and easily. So we want to be able to make sense of our environment. But before we get there, we have to recognize the stimuli that is in the environment when it arrives. And maybe you've experienced this before, when you have failed to notice something in the environment. Like maybe you didn't hear the air conditioning running until all of a sudden it stopped and you realized how quiet it was. Or maybe the opposite. Have you ever noticed that a friend's home has a particular scent to it, but you can't notice the scent of your own home? And why is that? So these are looking at what we call thresholds, our thresholds for noticing the stimuli in our environment. We all have them and they vary from person to person. An absolute threshold is when a person can detect a stimuli for the first time about 50% of the time, which means that it's so faint, it's so light, whatever that stimuli is. Maybe it's a sound, maybe it's a light, maybe it's a smell, but it's so faint that you only detect it at that level about 50% of the time. So you'll say, yes, I hear it, and then other times you'll be like, maybe I don't, because it's at the lowest possible level for detection. That would be our absolute threshold. Our difference threshold is when we can actually notice a difference. So we call this the just noticeable difference. So it's the minimal change that we need in that stimulation to be able to detect that change about 50% of the time. So turning the volume up slightly, whatever that slightly amount needs to be in order to be able to detect that it is now different. And this goes along with a concept called Weber's Law that tells us that when we're looking at that just noticeable difference, it needs to change by a constant percentage and not a constant amount. And what we mean by that is if you can tell the difference between 5 pounds and 10 pounds picking up weights, That makes a lot of sense because it is a 100% difference in the amount of weight you're picking up. But you might not be able to tell the difference between 100 pounds and 105 pounds. They might feel relatively the same because increasing by 5 pounds this time is only 5%. So if we can determine what the Weber's law threshold is, maybe it's 10%, you'll be able to tell the difference between 100 pounds and 110 pounds because that is the just noticeable difference for the change in weight threshold. But as time goes on, sometimes we don't notice information or stimuli that's in our environment. After a while, we get used to it, so we no longer feel it or hear it anymore. And that is known as sensory adaptation. When you're exposed to the same stimulus over and over again and it's not changing, our neurons are going to fire less frequently to let us know about it because it doesn't seem to be pertinent information to our brain. Think about if you've ever had your glasses on your head and you forgot where you put them, or put a watch on your wrist and wait to see it, and after a while you no longer feel it there. Those would be examples of sensory adaptation. But how do we know what our absolute thresholds and our difference thresholds are? There are a lot of different things that could play a role in whether or not a person thinks they feel or see a change when it comes to interpreting outside stimuli. Different personality types, for example. People who are overeager might have a lot of false alarms. People who are extra cautious might say they don't detect the stimuli because they want to be absolutely sure. So personality type and expectations can also play a role in detecting our absolute or difference threshold. Think about if you've ever had your phone on vibrate and you're expecting a call, you might keep checking it because you think you felt it vibrate. But if you're not expecting one, you could go all day without looking at it and be surprised when you find you've missed a call. Expectations and personality types will play a role in how well we can detect those signals. So we can use signal detection theory to try and help understand and maybe even give someone an incentive to change their behavior to find what the true absolute threshold is. So signal detection theory sets up how often a person says yes to the stimulus being present, whether they're accurate or not, or no. Do they have a lot of hits, but also a lot of false alarms? Or do they have a lot of correct rejections, but also a lot of misses? If someone has a lot of hits and a lot of false alarms, we can call them a liberal strategist or a yay-sayer. If they have a lot of correct rejections, but a lot of misses, we can call them a conservative strategist or a naysayer. And we can create what's known as a payoff matrix for someone who is a liberal strategist or a conservative strategist to try and give them an incentive to stop saying yes so often and learn to be more cautious. Or someone who is too cautious, give them an incentive to start saying yes more often. This would be great for signal detection theory if, say, we're looking for a qualified candidate. Someone who's in the hiring process who's too liberal or too conservative might hire a lot of really bad individuals or might miss some really qualified candidates. So by giving them some type of incentive, a bigger incentive for doing what they normally wouldn't do, helps to move them closer to what we would consider to be a true absolute threshold, so we can determine what the actual baseline is. In our next video, we're going to start diving into the senses themselves, talking about how this information from the outside world actually makes its way to the brain, starting with vision. So thank you so much for watching, and as always, remember, be kind to your mind.